I've described this congestion avoidance state as our steady state location. We expect to be in this state most of the time. But even when we're here, we keep adjusting the congestion window, so we should expect that eventually we make it too big and we end up in one of the other states. In particular, it turns out we expect to be in fast recovery, even when things are working well, where we make adjustments that drop the congestion window back down and go back into congestion avoidance mode. And if we look at this as a plot, we can look at the congestion window value that we currently have over time. We see that it starts out in the slow start mode, but slow start just means starting slow. It ramps up very quickly, and this is an exponential curve here, until we hit our threshold and we go into congestion avoidance mode. Congestion avoidance mode will linearly keep growing the congestion window until it gets too big, and then it'll go into fast recovery. And that transition into fast recovery will set our congestion window back to its threshold value, the same sort of value that we crossed to go into the blue congestion avoidance mode here. But fast recovery, if it works as expected, it does recover fast and we go back into congestion avoidance quickly. So overall, we end up with this sawtooth pattern where things are good and we keep pushing our luck until we go too far, and then we adjust and start over again. And the threshold can adapt a little bit as the congestion window size bounces around. This sawtooth shape is called additive increase, multiplicative decrease, because we're adding a little bit, adding a little bit, adding a little bit on the way up, and then we jump down based on some multiplicative factor, basically dividing by 2 to get down to the threshold each time. And this has some math behind it that says it's a good strategy for finding the right congestion window. Overall, we expect the congestion window to be about 75% of its theoretical maximum value if we had an omniscient TCP connection and had full control over everything that happens over the network. And 75%, while it's not 100%, turns out to be a pretty good target. Another good property of this system is that it's fair, because if everyone is playing by these same rules, they will all tend towards that 75% rate of what they could possibly best be doing if everyone do everything exactly and could cooperate perfectly. But no one gets left out. No one gets less than their 75%-ish share of what they should be able to do.